We start by selecting a default template as I assume there is no saved template. Now we are going to select a machine. This is done by going to the Home tab and selecting Machine Setup. Now that we have the digital twin of a DMG Mori M1 imported, let's get a closer look at the table inside the machine. In the machine view, there's a small eye icon. Clicking on this icon will usually bring up a menu with various options for hiding or isolating components. We can use this menu to temporarily hide the outer shell of the machine, giving us a clear view of the table. Now it's on to fixturing. While still in the machine setup, there's a fixture button. If we press that, we can go looking for the fixtures we need. I will be using a Lang base and 2 Lang vices in this project. As my Lang vices are identical, I will only be building one of them. Then afterward I will utilize the copy-paste function. Note that there are a lot of mounting points where I can put my second vice. This makes it really convenient to set up vices in various locations. Now, it's time to import the solid model we want to use. This can be done by either drag and dropping the 3D file into the part or machine view, or it can be done by going to the File tab and then selecting Import as I am doing here. We now need to align the part for proper machining. First, I'll focus on the Z-axis. To do this, I'll select the face on the model that I want to be my Z0 reference. Once the face is selected, I'll head over to the Manipulation tab and click the Align Z button. After aligning the Z-axis, I'll select the entire model. This allows me to create a bounding box around it. With the bounding box established, I can use the Move Origin function within the Manipulation tab. This powerful tool lets me precisely snap the part to various endpoints or midpoints of the model for accurate positioning. The little eye icon is also in the part view. Here, various elements can be toggled on or off. I'm toggling the solids off so I can select all the wireframe I created and delete them since they're not needed anymore. Now we'll focus on defining the part itself. Go to the Home tab and select Part Setup. This is where we tell ESPRIT about the part geometry and the raw material, stock, it will be machined from. ESPRIT offers several stock types to choose from: block, bar, or even a second solid already present in the part view. Additionally, you can import custom stock from an STL file using the From File button. I have chosen a block style stock, and now I have to define the stock. I know that the Lang vise clamps on 3 mm of the stock, so I align my height of the stock to the bottom and offset it 4 mm. This ensures that I have 1 mm for free stock before milling into the jaws. It's now time to head into Machine Setup via the Home tab and insert the workpiece into the Lang vise. This is done by marking either one of the vices or the base plate and clicking the Workpiece button. I will now offset the workpiece by quite a good amount so that I can locate the bottom of the stock and click it. Now I rotate the view so that I can locate the bottom of where the Lang clamps the workpiece. Remember to hold the Control button on your keyboard when selecting more than one item. Now select Alignment Mating as I do here, and the two selected surfaces should meet. Now everything is set up and ready to start applying some features and toolpaths. I start by finding all my pocket features. This is simply done by selecting the bottom of the pocket and pressing the Pocket button within the Features tab. Note that one of the pocket has open edges. This is shown by dashed lines. ESPRIT will take this as an indication that it can mill from the outside and the need for ramping or helicaling into the pocket is not needed. Now I will find hole features on the part. I start by selecting the face where I would like to find the holes. Then I make sure that all my requirements are set correctly, and in this case that it will only check for holes accordingly to my active coordinate system. And now I will find a wall feature by selecting the outer walls and clicking the wall button. Now I will start to add toolpaths to the part. I'll start with a facing operation, so I select the surface I want to mill and then I head to the milling tab and select the facing operation. Once selected, I'll go through all of the parameters and see if everything is to my liking. If stock automation in the general tab is set to yes, then ESPRIT will mill the entire stock instead of just the selected surface. Here I'm creating just a basic contouring path with a 12mm end mill. And again I'm going through the parameters just to check that everything is correct to my liking. When right-clicking in an expression field, there is the option to System Default. If done in the Total Depth field, ESPRIT will input the depth of the selected feature. Note that ESPRIT will save the things you put into the parameters for that specific operation. This can save some time the next time you open up a contouring or facing operation. The start point of the toolpath is not optimal here, so I would like to relocate it. This can be done by selecting the feature in the Feature Manager and then going to the Properties tab. Here a start point and end point are available, and by clicking in the expression field, I can digitize a new position in the part view. Now I'll rebuild the toolpath and it should lead in and out in the place I picked. To create toolpaths for the pocket, I'll select the feature I want in the Feature Manager and then head to the Milling tab and select the pocketing operation. Again, I'm checking all my parameters. I'm utilizing ESPRIT's profit milling and hybrid strategy, which is a trademark technology by Hexagon, and creates a sublime dynamic roughing path. I can now simply drag and drop the operation down onto my other pocket feature while holding the Control button to create a copy. This will force ESPRIT to try to cut that pocket with the same parameters as set before, and since we don't have any open edges on this feature, it will resort to helicaling into the pocket because that's what's set in the Rough tab on Entry, Exit. Now I will create a helix contouring on this oval slot by setting the process order to Depth and Spiral Move to Yes. This will create a helical toolpath of the contour where incremental depth is the indicator of the depth per full round of the contour. I'm giving it a little negative number in starting depth to make sure the helical toolpath starts above the feature. I'm also setting my lead in, out to distance and just a small number as I really don't need or want any lead in or out. Now I have to create some drilling, chamfering and tapping operations. That is done by selecting the drill/hole feature that was created earlier, then going to the Milling tab and clicking the Drilling button. Of course, we are going to select the desired tool and checking all the parameters. In the Hole section, Depth from Feature can be selected, and this will simply just read the depth of the hole feature and drill to that. I personally like to set the depth myself and therefore says no to this so I can set it myself. Right-clicking in the Total Depth expression field gives me the opportunity to set a system default, which is the depth of the feature. When the operation is created, I am simply copy-pasting the operation onto the hole feature to create a duplicate. Then by just changing the tool to a chamfer tool and setting the Use Chamfer Diameter to Yes and System Default in the Chamfer Diameter field, it will chamfer the hole. Copy-pasting the operation again and selecting a tapping tool and setting the depth and cycle type to tapping. I have also created the tap cycle for the holes. Now we are going to use ESPRIT's 3-axis deburring cycle. Here the chamfer tool is already pre-selected. If it's not when you open the cycle, please select one. By setting the chamfer type to deburr, ESPRIT will look for all sharp edges on the selected surfaces and deburr them accordingly to the parameters set. Note that it will collision check and trim the toolpath so that the tool does not collide with the part at the open pocket face. Then by simply copying the toolpath and setting the chamfer type to chamfer, ESPRIT will now look for any 45-degree chamfers and mill those instead of the sharp edges. For the fillet on the slot I milled earlier, I am going to use a freeform feature. Freeform is ESPRIT's 3D model-based milling system so that toolpaths correspond to the model itself instead of features. All operations for freeform are located in the Freeform tab. If this tab is not present, then contact your local reseller to hear about the freeform options available for you. I will use a between curves operation and set the tool and parameters to my liking and set the input type to looping surfaces to get a nice coherent toolpath. Now on to the second side of the part. Here I'm using the Add Setup button located in the Home tab. This will create a clean setup and I only need to mount a workpiece. Here the stock will follow the part from the first setup, so if any changes are made on setup 1, the stock will automatically be updated on setup 2 and the toolpaths will also be updated on setup 2. Simply place the part as done earlier in the video. Now rotate to the back side of the part in the part view and create a new work plane on the back surface. When that is done, we can create a facing and a deburring operation and our program is done. Thanks so much for watching. Hope this was helpful for you and a helping step to get started with ESPRIT Edge. And last but not least, don't forget to subscribe to our channel.